Alright, let's take a look at the same circuit we just solved for in example 10.3, where we did the mesh analysis, but instead of using mesh analysis, we're going to use superposition theorem to find I naught. Okay, so we're going to take a different approach here. Again, the circuit that we have is already in frequency domain form. And then if you remember the superposition theorem, essentially it says you take one current, source, you turn it off, you solve for the circuit, and then turn that back on, and then turn the second or whatever the number of sources that you have off, and then you solve for the circuit again. So what we're going to do here, because we're trying to find I naught, we're going to define I naught as equal to I naught prime plus I naught double prime, because we have two sources that we're going to be turning off. Okay, where we're going to say that I naught prime is going to be due to the voltage source, and I naught double prime is going to be due to the current source in this circuit. Okay, so to consider I naught prime, let's turn off, let's go ahead, and if we want I naught prime, we need to turn off this guy, and as a result we get this circuit down here. Alright, so it becomes an open circuit, and then you have this new circuit you're dealing with. So we're going to solve the circuit as it stands right there. So before we do that, we want to simplify it a little bit, and we want to say that our impedance, we're going to take our Z as the parallel combination. So the parallel combination between minus J2 and 8 plus J10. Okay, so we're going to take J10, 8, and then combine it with minus J2, and that's what we're going to use for our Z. So to do that, let's go ahead and type that out. Z is going to equal to minus J2 times 8 plus J10 over the sum of those guys, so over minus J2 plus 8 plus J10. If we simplify this and plug it into the calculator, we get 0.25 minus J 2.5. Okay, we'll keep this on the side. Okay, and we know from here our I naught prime is going to equal to J20 over our 4 ohms minus J2 plus this Z that we just solved for. So we plug those in here, get J20 over 4.25 minus J 4.25. Again, I'm skipping steps, but go ahead and pause and then work that out to ensure that you know how we got to this equation here. Or we can rewrite this equation here. I naught prime is equal to minus 2.53 2.353, excuse me, 353 plus J 2.353. Okay, so now we've solved for I naught prime. Next is to solve for I naught double prime. To do that, we're going to have to turn off this voltage source, and what that does, it gives us the second circuit down here, and when we turn off the voltage source, it becomes a short circuit. And now we're trying to solve for I not double prime. So to do that, let's do this mesh analysis for the second part of the circuit. Okay, so it's similar to the previous example. We can look at mesh 1. And that's 8 plus j 8 times I1 minus j 10 I3 plus j 2 I2 equal to 0. For mesh 2, we get 4 minus j4 I2 plus j2 I1 plus j2 I3 equal to 0. And then for mesh 3, I3 is simply our 5 amps. Okay, and then similarly, just as we did for the previous mesh analysis example, we just plug that in there. We plug in the I3 equal to 5 into those equations. So we got these guys here. We can plug in I3 for those, and then we can rewrite some of these equations. So let's simplify this a little bit more. We have 4 minus j4 I2 plus j2 I1, and in this case I3 is going to be 5 for the third component, so it's going to be j2 times 5, which is going to be j10 equals 0. And then we can rewrite the equation in terms of I1, which is going to give us 2 plus j2 I2 minus 5. Again, ensure that you understand how we're getting to this point. And now it's just a matter of substituting. So we have I3 here is equal to 5, I1 is equal to this guy here, and we just substitute into the previous equations and we solve accordingly. Let's go scroll up here. I'm going to go to the side. I have 8 plus j8 times 2 plus j2 times I2 minus 5 minus j50 plus j2 I2 equals 0, or we can rewrite this as I2 is equal to 90 minus j40 over 34, which equals 2.647 minus j 1.176. Okay, and so now we have our second part of this equation. So we have I naught prime is equal to this guy up here, but we know that I2, as previously done in the mesh analysis, I2 is really going to be I naught double prime, or in this case that negative version of it. So I naught double prime is really minus I2. Okay, so So which is minus 2.647 plus J 1.176. Okay, so actually I should have just highlighted this guy, okay, because the signs change, and that will make a difference when you're doing the polar coordinate system, because then the angle will also change. And so let's go back up here, and then we know that I naught, or I naught, is equal to I naught prime plus I naught double prime. Okay, and that's just going to be minus 5 plus J 3.529, and this equals 6.12 at 144.78 degrees amps. And this is going to be our final answer, and this should agree, this should be the same as the solution you came up with in the previous example 10.3, where you did the mesh analysis. So there are two different ways you can approach it, more than two different ways to approach your solution of these circuits. In this case, maybe the superposition may have been an easier version, as opposed to using the mesh analysis from the beginning. So this was the superposition theorem for the same circuit as example 10.3, and we use that to simplify our circuit and to come up with I naught and frequency domain. Okay.